Hello and a very good morning to all of you. As promised in the previous lecture, today I'll be making a new video on the subtopic of speed, distance and time, that is trains, right? Now, for this topic you need to remember few points which I'll be discussing right now. The first point is that the length of the train a bridge or a platform will always be taken in meters, right? Always in meters. Our second point, the length of a man or a pole or a tree or any such point objects will be taken to be negligible. That means we will not consider it, right? Our third point. The third point is that whenever a train, right, is crossing a bridge or a platform, the total distance will be always the sum of the length of train plus the length of the bridge or length of the platform. Clear? Our fourth point. Now our fourth point is that whenever two trains are crossing each other, whether in the same direction or in the opposite direction, the total distance will be, in that case, the sum of lengths of both trains, right? Sum of length of both trains. Okay? Now we have talked about pretty much the case of distance over here. Now we'll move to our case of what? Speed. The time will remain the same in everything, in every question rather. That will be seconds. Okay, generally in seconds. Now we come to an important concept called our relative speed. Now, what is a relative speed? See, in this case, what we will do, whenever two trains are moving in opposite directions, right, and the speed of the first train be s1, the speed of the second train be s2, whenever they are moving in opposite direction, their relative speed will be s1 plus s2 always, right? The second point we need to remember is then where they are moving in the same direction, right? The relative speed will be s1 minus s2, where s1 will be our faster train and s2 will be our slower train. Now, once you have noted down these points, we are clear to move with our questions. Now, moving forward, we'll be doing our first question upon the topic of trains, right? It will be a very basic question. We are given that a train with a speed of 60 kilometers per hour passes a pole or a man in a time of 9 seconds, right? What we have to find? We have to find the length of the train. In the topic of speed, distance and time, and in the subtopic of trains, we have to make sure one thing, that the word length will be synonymous with the word of distance, right? Now first of all, we have to make our units same, so we will convert our speed. We know that 1 meter per second is equal to 5 upon 18 meters per second. sorry, 1 kilometer per hour, right? So we will multiply it into 5 upon 18. So we will get 6 3s are 6 10s are. So we get our speed in meters per second as 50 upon 3 meters per second, right? And the time we are already given. So for finding the length or the distance, what we will do, distance is equal to speed into time, in this case 50 upon 3 into what? 9. 3 ones are 3 threes are, and we have the length of our train as 150 meters, right? A pretty basic and a clear question. I hope you all got it. Moving further, now comes the tricky part, where we will be actually given the scenario of two trains, right? Now we are given that two trains are moving in the same direction, right? One is moving at a speed of, let us say, 36 kilometers per hour, and the other one is moving at a speed of 46 kilometers per hour, right? The faster train crosses the slower one in a total time of 36 seconds, right? Given that they are both equal in length, here is the catch, they are both equal in length, right? We have to find the length of the each train. Clear? Now, if we just wait and visualize, we will frame our question first. First of all, we'll be need to find the relative speed. Then we will convert it into meters per second. Also, we are given that they are moving in the same direction, which means that their relative speed will be 46 minus 36, right? 10 kilometers per hour, we will change it into meters per second into 5 upon 18, right? 2 9s are 2 5s are. So we have 25 upon 9 meters per second as the relative speed, right? Now they cross each other in 36 seconds. First of all, we will let the length L1 be the length of the first train, be x. So the L2 will also become x as they are equal in length. The distance, as I told you before, will be always the summation of both the lengths of the train. That will be 2x, right? So now applying the formula of we'll frame our question in the formula of time. Time is what? Distance upon speed. Okay, so 36 is equal to distance upon what? Speed. 25 by 9. So it will come out to be 2x upon 25. This will get reciprocal 9 and 36, right? 9 ones are 9 fours are. Clear? Now we'll cross multiply 25 into 4. So we will have 2x is equal to 25 into 4, 100. Or x will come out to be as 50 meters. And we have found out the length of both our trains as 50 meters each. Right? Such a simple question. I hope you all got it. Moving on. So moving on with the third question. Now comes our case of opposite direction, right? I'll write opposite beforehand only. Now the question is that two trains, each 100 meter long, right? 100 meters long, are moving in opposite direction. And while doing that, they cross each other in a total time of how many seconds? 8. Right? Now we are given the catch. The catch is that the speed of the faster train is twice that of the slower train, right? And we have to find the speed of the faster train. Okay, now again we will frame our question first. Very basic. Opposite direction, which means that their speed will be added, right? So let S1 be the speed of the slower train, right? I'm writing in bracket slower. Bx, so S2 will be twice of the speed of the slower train, that will be 2x. Fine. Now mind it that the speed I have taken is in meters per second, right? Because I have given the time in second and the length in meters. Fine. So their relative speed will be 2x plus x, 3x meters per second. I hope that is clear. Now the distance will be again the summation of the lengths of the both of the trains. That will be 200 meters, right? The time is again 8 seconds. So we will frame our question in that form. Time is equal to distance upon speed. Distance upon speed. See, mark one thing, that this sign, what it means, this sign is necessary, as it means this implies, right? Don't confuse it with an equal to sign. Now 200 is equal to cross multiply 24x. Now we'll cut it by 4. So 4 6 are 24, 4 50s are 100, 200. Now 2 3s are 6, 2 25. So x comes out to be 25 by 3 meters per seconds. Okay, but again note one important thing, that we have found the speed of a slower train. We are yet to find the speed of a faster train. So we will multiply it by 2 because of this formula. So now we will get 50 upon 3 meters per second, right? Now we were given this speed in meters per second. You can leave it here, or for the sake of simplification, right, or to making the teacher understand that you have understood the chapter well, you can convert it into kilometers per hour. Multiply it by 18 upon 5. 5 ones are and 5 tens are, right? 50 by 3. 3 ones are, 3 6 are, and it comes out to be 60 kilometers per hour. And the speed of the slower train will be half of this, because it was twice the speed of the slower train. So we can calculate this to be 30 kilometers per hour. I hope it is clear to all of you, right? See, you have to frame the basics of the question first in your mind. Only then you will be able to solve it step by step. Moving further, now comes our concept of bridges and platforms. Nonetheless, in this case, you will be also adding the length of the bridge or the platform in the length of the train to take out our total distance. Okay. Now we are given a train, question number 4. A train of length 300 meters, right? It crosses a man or a pole, let us say, in a total time of 18 seconds, right? And it also crosses a platform in a total time of 39 seconds. Okay, what you have to find out, you have to find out the length of the platform. Clear? Again, what you have to find out, let it be x. So let the length of platform be x meters. Again, see, using our first case, we are given the length, that is the distance, and we are given the time. So we can find our speed. So our speed of the train will be distance upon time, that is 300 upon 18. 6 3s are 6, 50s are. So 50 upon 3 meters per seconds. Fine. Now we have, for the second scenario, we have our speed and we have our time ready. Now we will use this, right? Now for the second case, we will have our distance to be 300 plus the length of the platform, which I told you before, which will be x, right? Distance will be this. Now again, using the formula of time, we will have distance upon speed is equal to time. So 300 plus x upon speed is how much? 50 by 3, which when reciprocal will be 3 by 50 is equal to 39. Clear? Time. 3 1s are 3, 13s are. Now 50 will be cross multiplied with 13. So it will come out to be 300 plus x will be 5 into 13 is 65, and the 0 will be carried with it. So 300 plus x is equal to 650. Now we will take our 300 on the right hand side and we will get our x as 650 minus 300, that will be 350 meters, and voila, we have found the length of the platform to be 350 meters. Now from here on, you can very well what you can do, cross check your question. Okay, now for example, hide this time, right, and take the length of the platform to be 350 meters, right? I'm only cross checking here. My total distance comes out to be how much? 350 plus 300, that is 650. My speed was 50 by 3, which when reciprocal gave me 3 by 50. I cancel out the zeros, then 5 1s are 5, 13s are. 13 into 3, the train again crosses the platform in a total time of 39 seconds, right, which was given to us in the question. So this way I can very well cross check my answer also, right? I hope it is clear to all of you. Thank you. Now moving forward, and to our last question we arrive, right? I am putting a star in front of it, right, to highlight the importance of this question. I call these types of question to be bomb questions, right, because they really open up all your concepts of the topic. Now we are given that two trains are moving in opposite directions. Clear? And they cross a man in 17 and 27 seconds respectively, and they cross each other in a total time of 23 seconds, right? What you have to find is the ratio of their speeds. Now please have a careful look at the question, because you are given very limited knowledge. Please look at it, or you can pause the video and think about it. Right. Now if you notice, we have to find the ratio of their speeds, right? So we will let their speeds be what? in two variables x and y. Let its speed s1 be x and this be y. Clear? Again, the question is in the format of time. So we need to find out the distance. For distance we know, I'll make it my first case, that distance or the length of the first train, right? It is what? Speed into time, and they are crossing a man. So the length or the width, anything of the man, will be taken to be negligible. So we will straight away multiply 17x, right? Similarly, our d2 will come out to be how much? 27y. Clear? The total distance will be, coming to our second case, the total distance d3 will be 17x plus 27y. Our relative speed will be the summation of x and y. Why? Because they are moving in opposite direction. And we have a question ready, right? 17x plus 27y upon x plus y is equal to 23. Time is equal to distance upon speed. Now I hope you can all solve it. So doing it quickly, we will get 17x plus 27y is equal to 23x plus 23y. Moving forward, we will bring the terms of x on the left hand side and that of the y on the right hand side. So moving this here and this there, right? What we will get? We will get 23 minus 17 will be minus of 4x, and this we will find out to be minus of 6x, right? Now our minus will get cancelled, right? And we know that 2 2s are and 2 3s are, right? So 2x upon 3y is equal to 1, or x upon y is equal to 3 upon 2. That is, we have find out our ratio of the speeds to be 3:2 respectively, right? I hope it is clear to all of you. Thank you. Please like and subscribe to my videos if you want me to make more videos on such topics further, right? Thank you all of you.